So in continuation to the previous video, in order for us to use the second method, which is called Saros rule. Saros rule, okay? Saros rule is the most easiest way to find the determinant of a 3 by 3 matrix. And how will you go about it? Saros rule says that if you want to find the determinant of this 3 by 3 matrix, the determinant of 3 by 3 of this matrix simply implies that you are expected to repeat. This is 1 4 minus 1, this is 2 2 3, and this is 1 minus 3 minus 2. Saros rule will now ask you to what? Repeat what you have on this first column and the second column at the extreme in this matrix. This is the first column, which is 1 4 minus 1. Repeat it here again. 1 4 minus 1. And this second column, which is 2 2 3. This method is the fastest way to find the determinant of a matrix. So when you have done this successfully, so whatever you have to do next is to consider this first row. Looking at this first row, the number that falls in the middle is this particular point here, which is 1. So this one falls in the middle in this first row. So therefore, our final answer is you need to multiply, starting from this position, you need to multiply it from left to right diagonal, multiply this together, left to right, and then give the result. 1 times 4 times 3, that is 12. Noted. Then you are not expected to go upward, you are expected to come downward like this. After multiplying this one, then you need to come down a little bit, go to the next value, which is 2, like come towards this down part, okay, left to right, downward, okay. If you start from here, you are not expected to go upward, you have to come downward this way. So this is the next one, downward. 2 times minus 3 times minus 1, that's minus 6 times minus 1, that is 6. Done. And then the last one is this, okay, left to right diagonal. 1 times 2 times minus 2, that's what? Minus 4. Sum all these things together and then get your answer. 12 plus 6, that is 18. 18 minus 4, 12 plus 6 is 18. 18 minus 4 is 14. Done. Then the next thing, we've done the left right diagonal. So whatever we have to do next is now the right to left diagonal. Multiply this together. 1 times 2 times minus 1, that is minus, minus 2. Then you come downward. Next one is this. 3 times minus 3, that's minus 9. And then the last one is 2 times 4 times 2, that's 8. 8 times minus 2, that's minus 16. Okay, 4 times 2 is 8. So you have to add all these things together. And if you add this together, you should know that that should be minus minus minus. That's minus. Minus 2 minus 9, that's minus 11. That's minus 11. And minus 11 minus 16. Minus 16, that should be minus 27. So I have minus 27 here, right? I have minus 27. Okay, so therefore this is right to left, this is right to left, this left to right multiplication. So you have to, for our final answer, the determinant of this matrix A is right to left minus left to right. So what's right to left? That's 14. Minus what's left to right? That's minus 27. So when you simplify this, you have minus, we have 14 plus what? 27. And what's 14 plus 27? That's 1 1 2 3 4. You see, it is exactly the same result that we got previously in our previous video. So I prefer to use this method rather than using Laplace expansion of determinants. So this is faster. Just multiply this together, this, and then whatever you get here and whatever you have here, so remove this thing from this, then to get a final answer. Just do for the right to left diagonal, the sum of the right to left diagonal, the product of the right to left diagonal, minus the left to right diagonal. So that's how it works. Okay, it's very, very direct and very, very easy to work with. So the determinant of this matrix is what? Is 41. So very, very easy. Exactly with this, with the same results we got previously. So that's how determinant works. For 2 by 2, for 3 by, nobody will ask for 4 by 4. So take note of this explanation. Okay, I've tried my possible best to break it down. So the next thing for us to do is to talk about inverse of matrix. Okay, so then I think with that we should be able to solve more questions on past questions. Thank you.